Okay, good afternoon, class. Welcome, and I hope everyone is ready to learn some concepts and also the right attitude towards working on a research. Okay, so this will be part of basic statistics, and this is part 1 of our lesson for this day. Okay, why do we need to learn about this topic? On your own, try to fill up this circle on why we are in this topic. What is it that you probably would like to learn or will have to learn in basic statistics so that you may be empowered to work on a research topic for your thesis paper? And what will be the use of learning basic statistics? Okay, you again fill those portions of this circle, and hopefully that would provide for you a goal so that when we are able to deliver the part 2 of this, which will be demonstrated activity on how you handle data to generate basic statistics. So we are in this together. Let's try to have the adequate attitude as well as the motivation to understand basic statistics for a specific research. Okay? A researcher generally at your level will have to work with a mentor who supervises, provides motivation, as well as pacing so that you do not lose your enthusiasm as well as your direction towards the realization of your research objectives. So what are the responsibilities of a researcher? Researcher gathers data, consolidates data, prepares the reporting formats, okay, generates the report, and analyzes the data, matching your discussion with specific objectives declared in the first chapter of your paper. But when one develops his or her own topic, the preliminary activities would be to meditate on the topic, okay, prior to the determination of the research problems or how one will have to gather the data required to be able to resolve the stated research problems. Okay, so what are the required competencies of a researcher? A researcher must demonstrate personal effectiveness. That means from your own volition or initiative, you will have to declare yourself capable of completing the study. A researcher also must speak effectively in that one requires to have the technical perspective of a researcher. We're not here to make our own opinion or to interpret the data according to our own biases. As previously stated in our discussion, we will have to let the data speak for themselves. So the major player or actor in any research, it would have to be the data as generated by the research process. Okay, while the researcher is the one conducting the study, it is the data which will dictate on how, why, or what the statement of the problems will have to be resolved with, or on what grounds one will have to develop any specific output that has been declared as the bootstrapping bootstrapping usefulness of all of the research results. Okay, a researcher must also be able to write effectively. When we say effectively, the research is tailored for a specific audience, which will have to be those who are in the technical field of your field of specialization. And a researcher must also champion and apply the innovative perspective to problem resolution. You start with a problem, you generate the data, you analyze the data for the resolution of the stated problems. When your data falls short of resolving the problem, you will have to supplement your research results with secondary data or with the results of other researchers so that one can provide adequate basis for resolving the stated problems. Okay? And one must also plan and deliver research results. Plan the research methodology and then deliver the research results. A researcher also needs to be able to manage information, okay, such that he is able to deliver that via technical discussion of the results. When we say technical discussion, it will have to be short, simple, and elegant. Okay, what are the intermediate competencies of a researcher? The intermediate competency of a researcher will have to be the ability to work with data so that one is able to generate relevant information. And how do you generate relevant information? When you conduct any research, you will always have to provide the whole window for the research. That means you will have to look at the initial stage as complementary to the final stage. That means you will have to look at a wide perspective for initiating the research as well as completing the research. Relevant information means that any data you generate is precisely for the resolution of the research problems. Okay. Now, when we say we need to generate relevant information, we would also like to highlight or emphasize that relevant information will have to be defined as reliable statistics, which means that the units of measures adapted for the study as well as the method of measurement and the means of collecting the data are all valid and respect the processes of science. Okay. Even when you work with, let's say, qualitative research. Still, you will have to anchor everything, every step of the research process into the core values of generating quality data, so that information generated by this data will have to be, okay, valid and could be verified should there be a need to verify the results. Okay, when we look at the fundamental principles of official statistics as declared by the United Nations, we refer to official statistics as relevant, impartial, and is available for equal access by anyone who may need those information or data. Okay, and it has to abide by the professional standards, scientific principles, and professional ethics. We cannot overemphasize the need to observe professional ethics in the generation of data. This is something that we will have to all really understand, okay, and internalize as the guiding principle of any researcher. Once you are able to feel that you may have the small window of tweaking your data or slightly manipulating data, then you break this requirement of abiding by the professional ethics for research. Okay? And generating reliable statistics or official statistics will require accountability and transparency, and this will have to be declared in your research methods. Okay? And that we prevent misuse of data. How is this possible? How is this done? How is this type of misuse committed? Sometimes deliberately, sometimes inadvertently. Misuse of statistics is when you present data without declaring any form of information that a user of your data will have to know about, such as, let's say, if you initially had to work with a given sample size and you were unable to reach the target respondents for some reason, some valid reasons, or because of unavoidable circumstances, when that is the case, you will have to declare that there is this kind of limitation to the inclusion of the declared sample size. Okay? And we have to also understand that there are official sources of data. We said that when you're unable to completely answer or resolve your research problems, you might have to use secondary data or somebody else's data with permission. Okay, so you will have to understand which of the agencies will generate reliable data. Okay, so let's say if you believe that DepEd meticulously tracks the kind of data that you require, then you can use their data. Should you get hold of any form of assessment, technical assessment, that there have been some rules which were transgressed in the generation of data for a slice of DepEd's database, which you will have to use or access, then do not use that data source. Use an alternative source which data are valid and scientifically reliable. When we have official statistics, we say that these official statistics will be covered by the confidentiality clause. That means that when you declare that your sources will not be personally identified to protect their privacy rights, then you will have to maintain confidentiality. Okay, some legislation will have to be observed, such as the right of the respondent to be informed of the utility of the information or data that they will provide. And so there are ethical boards which verify if your research methodology abides by the rules of ethics in terms of data collection. And also official statistics will require national coordination. Okay, so let's say you will have to use assessment criteria if your results will have to be relied on as a standard that mimics that of any official agency mandated to make that assessment, then you will have to respect the coordination required for such kind of official statistics generation. Okay, example. If you will, let's say, use teachers of the Legazpi or Albay division, schools division, you will have to coordinate with both DepEd and the specific schools identified as part of your sample. If and when you will cross agency mandates, let's say you're going to look at gender and development issues, you might have to coordinate with the gender and development focal person at the level you're working. If you're working provincial-wise, at the provincial level, you will have to go for the GAD focal person, regional level, or schools division level. Okay. And the use of international standards, we said previously in our discussion, will have to be observed once you use units of measures which implicitly will also address similar sections, similar sectors of concerns. Okay, and when you, let's say, when you look at literacy, that's an international type of cooperation, understanding that the Sustainable Development Goals addresses literacy. If you're looking at, let's say, the capacity of um, manpower to provide their contributions to the economy, you're also addressing sustainable development goals. So, and all of these are parts of your study. You will have to um, be able to recognize that there are levels of interlocking, okay, interlocking concerns that you need to address and respect or observe as part of your restrictions or as part of the measures for your study. So what are the basic concepts in statistics which we will demonstrate initially in the second part of this discussion? So we have measures of central tendency, measures of dispersion, and measures of location. We also will have to understand population, sampling, okay? And sampling will always need to recognize the principle of randomization, and that we also will have to understand that there are always errors in any research methodology as well as in the generation of data. Okay, and statistics will always talk about probability and probability distributions, and that we have basic tools of statistical analysis. From the descriptive form of statistics, we can move towards inferential statistics. And some of those tools which you will learn in this class will be correlation, analysis of variance, regression, and all those hypothesis testing concerning the mean or rate or standard deviation or ratios. Okay, so we will have to look into these forms of statistical tools of analysis. Okay, what will be your job in this class? Okay, some of the tools that you will need to be able to complete your requirement for this class is for you to, okay, be receptive to the need to use the spreadsheet. Okay, also you will have to decide that you have the capacity um, to taste, digest, and savor the substance of your own study, which means that you will have to provide depth and meaning to your study relative to substance as well as technical considerations. Also, for the third, you will have to identify a methodology that is apt for your research, not just picking up anyone's methodology, but rationalizing it as appropriate for your study. For fourth tool that you will need to use numeric language or quantitative language, which means that the quantitative logic of statistics will have to be a perspective that you will have to adapt regardless of whether your study is quantitative or qualitative in nature. We explained why, for data analysis, qualitative research will have to approximate the methodologies of quantitative research. While there are researchers which are intrinsically qualitative in nature, but because of the requirement that one who pursues qualitative research must be an expert in that field, we are not yet at that level. Hence, the need to translate qualitative data into their quantitative equivalents. Another tool that you will have to use or need would be the ability to proactively declare your table presentation, as well as the forms of data presentation, be it in the form of tables, graphs, or visual rendition of how the data behaves. Okay, so it's dependent on what you really would like your readers or intended users for your research result will have to appreciate relative to helping them go up at least one step up the ladder of refining the issues, okay, that your research problem address. Okay, so another tool that you will have to use would be the ability to um, sift through your data and use the least form, the simplest form of your data as part of your basis for resolving your research problems. Okay, so it's a tall order, but we just will have to go slow in realizing the use of those tools, and then there is nothing to fear. So for descriptive statistics, we will learn how to compute the mean, median, variance, and standard deviation. So I will provide an example for this on how you generate these measures of central tendency and measures of dispersion, and why this will be relevant to the analysis of your data. And we can work with this descriptive statistics using analysis toolpack, which is provided for in MS Excel, so you do not have to manually compute or use calculators. Also, we need to understand the rule of thumb and the technique for identifying outliers. So what do? We compute the average, the mean, median, and mode, standard deviation, skewness, and the interquartile range, which you will appreciate when you get to see that it's a very visually effective means of comparing sets of data. Okay, we will learn how one can use interquartile range as a reference for making conclusions about how the data behaves. Okay, some of you might need geometric mean and compound annual growth rate if you're looking at time series data, such as when you would like to study how, let's say, non-readers might balloon into for a particular set of students or for a particular zone of schools. Okay, what do we do with the Pareto principle, which is the 80-20 rule? This is a rule of using data such that when you have the complete data set, one is used for testing the model and the other is used as the actual data for refining the model. So we use the 80-20 rule, known as the Pareto principle. So what do? We divide the data set into two. We split it into an 80-20 split. Okay. And what do? Okay. We work with the testing data, and then we use the other set for the verification if the model works. Okay, let's say, suppose you would like to check if what you have come up with would be a good approximation of how to identify non-literate students at a specific grade level. So using the entire data set, you split it into two. Use the first 20% as your testing data, and then refine the model, and then the 80% will be used for validating if the model, okay, developed by using the 20% really works. Okay, you can also split your data into 60-20-20, okay, but all of this will have to be validated on why you're using that kind of split. You just do not out of the blue decide on how you split your data. There must be some related literature and studies you can use or invoke similar to the topic under discussion. Okay, so why do we need to cross-validate models? When we say models, that means once you are able to complete your study and then you offer a particular intervention, what you really are supposed to do is to be able to test that intervention as being effective. And you do that by testing or validating that model. Okay, so why do we need to understand these basic principles of statistics? Because statistical logic is a method of looking um, at anything or any phenomenon from the perspective of reason. Okay, we all have so much of that, and we will use that to be able to render the characterization of any phenomenon from the perspective of someone who is open to validation of statements derived from data generated specifically for that research. So the logic of statistics works as a method of looking at something with the goal of being open to being questioned about how the data was generated and why the data is adequate to be able to resolve the research problems. Okay? And what, if anything, must be done in refining the method for the generation of the data. And why you say so? Because when you are able to complete the study, you will have to openly declare with accountability and transparency as core principles of such declaration that given this kind of study, one bumps into inherent difficulties or difficulties that are most most it's like it's you know entrenched into the system. Like if we would like to validate if, let's say, a specific set of teachers are effective mentors, let's say, yung grade 1 to 3, like preschool, or I don't know what you call the grade 1 to 3 primary level, or if you would like to verify the transition from grade 6 to grade 7 as an adequate transition, then you will have to declare with accountability and transparency on what the difficulties in characterizing that transition are, as you have experienced it, and how one can minimize the discrepancy in the measurements for that um, transition to mirror, okay, the true realities of the grade 6 being the transition phase towards grade 7 or the junior high level. Okay, so in statistical logic, we are very open to being scrutinized as to why we say things as they are, because we are rooted on the rules of science and we use the techniques of reason for declaring any form of data as reflective of the phenomenon that we would like to address. Okay, so let's look at descriptive versus inferential statistics. Descriptive statistics is concerned with describing the population. It's also concerned with organizing, analyzing, and presenting the data in a meaningful manner. For descriptive statistics, the final results can be in forms of charts, tables, and graphs. Okay? And the data is known. What are the tools we use for descriptive statistics? We say we use descriptive statistics, which will be a roundabout way of saying things, and we're not able to clarify what that descriptive statistics is really about. So the tools we use for descriptive statistics will be measures of central tendency and measures of dispersion. For inferential statistics, this will be the deeper form of statistics, the more meaningful statistics, in that the conclusions that you derive from inferential statistics will be those that may be verified as statements that can be used, okay, for the future or for another set of population similar to the one addressed by the study, or the population addressed specifically by the study. So inferential statistics is concerned with making conclusions about the sample and generalizing these conclusions as applicable to the population. It compares, it tests, and predicts future outcomes. Okay, and the final result of inferential statistics would be based on a probability measure, and we normally look at this as the significance level. Okay, inferential statistics also tries to make conclusions about the population and is not beyond the data and is beyond the data available. The tools it uses will be hypothesis testing, analysis of variance, regression, clustering, forecasting, trend analysis, paneling. There are just so many of these. We are not saying that we are trying to impress you with all the tools, but the tools of statistics are meant for specific objectives and design of research. Okay? So, what are two types of errors in hypothesis testing, which we will address when we cover inferential statistics? Okay, the two types of error would be that we have the false positive and we have the false negative. Okay, so this we will understand as we go for hypothesis testing. Okay, once we're clear with descriptive statistics, and as we have decided in our first two meetings that you always bring with you your own study to be able to understand what we mean by false positive and false negative. Okay, and what do we know now as the power of the test? Okay, the power of the test would be those that tell us how we are able to um, to put credence or credibility on the statements that we generate when we provide conclusions based on hypothesis testing. Okay, so this is where we end part 1 of our discussion for today. Part 2 will be the demonstration of how one handles data to generate descriptive statistics. Thank you for your kind attention. Let me know of your problems, of some clarifications that you need so that we can optimize your understanding for this phase of our topic for today. Thank you very much.